Okay, let's work of the an example of the partial derivatives. In this case, higher order derivatives. Please take in consideration that if you are going to calculate the third derivative or the fourth derivative, the procedure is going to be the same. The only difference is that you need to pay attention with the terms that you are working with in order not to get confused. But you take notes and indicate each one of the steps, and the you are respectful or the of the differentiation rules, you will be fine while calculating this type of problems. Okay, so let's work with this example. We have this function f of x and y, and that is equal to x cubed plus x squared times y cubed minus 2 times y squared. And as you know, the partial derivative of this function with respect to x equals 3x squared, which is this part, plus 2 times yx cubed, which is this one. And this term 2y squared is equal to 0 because this is considered as a constant. Okay, so this is the partial derivative with respect to y. This is equal to 3x squared, which is the derivative of the y term. And this is the n minus 1, which is y squared, and x squared is because it's a product, we're going to keep it in the same expression. And in this case, 2 times 2 is 4, y squared n minus 1 is just y. So we have this partial derivative with respect to y. Okay, so let's calculate the first one. Let's say that we need to calculate, let's say, f sub x. And this is equal to, let me write it this way to avoid any confusion, x squared plus 2 times xy cubed. Okay, and this is going to be equal to 6 times x plus 2 times y cubed. This is the derivative of this, and this is the derivative of this with respect to x. Derivative of x is 1, and we are not applying anymore any other function here or any other operation. We are going to keep the 2 on the y cubed because this is a product within the xy function. So this is the second derivative with respect to x. Okay. Now let's calculate f sub xy, and this is going to be equal to the partial derivative with respect to y, in this case, of the one that we already have here, which is the one with respect to x, plus 2 times x y cubed. And this is simple if we are going to apply only to this term because we have no y's here. This is equal to 6xy squared. Okay. So this is the second derivative from with respect to x and then with respect to y. Okay, let's do the third one. This is, let's say that this is f yx, and this is going to be equal to the partial derivative of the function with respect to x, but now from the y function, which is 3x squared y squared minus 4y. Okay, and if we apply the partial derivative of this is the partial derivative with respect to y, and if we differentiate with, but now with respect to x, we will end up with 6 times xy squared. Okay, and if we do the fyy, which is the partial derivative with respect to y, but of the function that is the first result with respect to y, which is this 3x squared y squared minus 4 times y, and this is going to be equal to 6x squared y minus 4. Okay, and that's it. Now you have 4 examples of how to calculate the second order partial derivatives of a function. It's a little bit tricky. It's not that hard if you have your differentiation tables. You can confirm your results in calculator. Later on, I'm going to explain you how to use some types of software so you can validate your results there. The only thing that is turning this a little bit tricky is because you need to know which one is going first in the first place, and then how can we proceed with the second one. And I think the best way to do it is ordering here the 4 expressions and take first the first derivatives here and then express it in this way. So we can take, if this is f of x, we are going to take this f of x and going to put that right here. And then once we have this already here, then the second step is to evaluate that or differentiate that with respect to y. So that's maybe a tip for you. Maybe you can find your own way to calculate this a little bit easier. But this is a brief explanation of how it's done, in this case, the higher order partial derivatives.